let us look at deriving the Laplace transform of the cosine of AT. Now, in a previous video, we saw the Laplace transform of the sine of AX. But remember, sometimes the horizontal axis is labeled as t, where t is usually used to represent time. Alright? So, here now. The fact is that in an exam, you would have a table of Laplace transform, and the cosine of AT would be there. So you could use it. But you might be asked to derive the cosine of AT. So that's what we're going to be doing here. Now, the formula for the Laplace transform is the integral from 0 to infinity of e to the negative st cosine of AT dt. Now, what we have is an integral of the product of two functions of t. There's e to the negative st, and then there's cos AT. So what we'll do is use integration by parts. Remember, with integration by parts, the integral of u dv is equal to uv minus the integral of v du. Alright? U and v are functions. Now let us take u as e to the negative st and dv as cos AT. So u is equal to e to the negative st. dv is equal to the cosine of AT. Therefore, du would be equal to negative s e to the negative st, and v, when you integrate cosine, you get sine. So in this case, it's going to be sine AT divided by a. Alright? So remember that this and this. To go from u to du, we use the chain rule. We differentiate using the chain rule. In other words, we use substitution. Then to go from dv to v, we use integration by substitution. Alright? You have to remember that. So now, let's call this, what should we call this? I1. Let's make up a name for it, because I know we're going to do integration 2 times. The first integral is the integral from 0 to infinity of e to the negative st cos AT dt. So in this case, the integral of u dv is equal to u e to the negative st uv, which is sine AT over a, minus the integral is from 0 to infinity of v, which is sine AT over a, du, which is negative s e to the negative st dt. Alright, good. Now, I1 is equal to, it's going to be e to the negative st. Let's rewrite this. E to the negative st is the same as you have to remember your rules of indices. It is 1 over e to the positive st, that will be over a sine at. Alright, minus, well, we have a minus here and a minus here, so we'll end up with a plus here, plus s divided by, we have the constant a under here, over under a, so we put s over a outside the integral sign. So we have the integral from 0 to infinity of e to the negative st sine at dt. Alright, so that's what we have. Now we want to concentrate on this, so we will be looking at this part. What we want to do is find the integral from 0 to infinity of e to the negative st sine at dt. Then we'll come back to this later on. Alright? Now, we use substitution. Not substitution, integration by parts. In this case, we let u be equal to e to the negative st dv is equal to sine at, du would be negative se to the negative st, and v is equal to, well, when we integrate sine, we get minus cos, so it's going to be minus cosine of at over a. Alright, so what we have is the integral from 0 to infinity. Let's not rewrite that. Let's keep it as it is. Oh, we could call it I2, you know, the second integration that we're going to do. Let's call it I2. We called the previous one I1, so let's call this I2. Now this is going to be the integral of u dv is equal to u, which is e to negative st, uv, which is negative cos at over a. Let's put this in bracket so that it doesn't seem as if we're subtracting, minus the integral of v, which is negative cos at over a, times du, which is negative s e to the negative st. Alright, so let's fix this up a bit. I2 is equal to, going to be negative e to the negative st cos at over a. Alright, now this is going to end up as a minus, because what happened, we have a minus here, a minus give you a plus, then a third minus give you a minus, so it's minus. Let's take the constants out. We have an s here, there is s over, we have an a here, so it's integral, and remember we're integrating from 0 to infinity, from 0 to infinity of e to the negative st cos at dt. Alright, so now let's look at this part. Let's concentrate on this part here. Does it look familiar? Integral from 0 to infinity of e to the negative st cos at dt. the integral from 0 to infinity of e to the negative st cos at dt. So this is the Laplace transform of cos at. So this is the Laplace transform we're trying to find. Now, here. What we're trying to find is the Laplace transform of cos at. That is equal to what? Alright. Now you see all of this thing here is this. So let's put back this part there. What we have is 1 over e to the st sine at, 1 over e to the st sine at, right, over a, this is over a, right, plus s over a times the integral from 0 to infinity of e to the negative st sine at dt. This part is what we call I2. Now, this is all of I2. So let's put it there. It's negative e to the negative st is the same as 1 over e to the positive st, and that multiplies cos at, all of that is over a minus, then we have an s over a. Now, integral from 0 to infinity of e to the negative st cos at dt. But remember now, this part is the Laplace of cos at, as you see here. So let's write it as the Laplace transform of cos at. Alright. Now, what we have here now, we want to fix this up a bit. The Laplace of cos at is equal to 1 over e to the positive st sine at. Let's just put sine over it from now. Oh no, let it remain. On second thought, let it remain. This is over a plus. Let's open this bracket. Oh, we didn't close the bracket here, you know. Okay, good. Let's open this bracket. Let's multiply out. So we have this is going to be s multiplied by this. So this is going to be s over negative e to the st cos at all over a times a. So that's going to be a squared. Alright, so after that we have minus s will multiply s here, so it's s squared over a times a over a squared times the Laplace of cos at. All right. Remember now, what we can do is add. Let us add this part to both sides so that we have the Laplace together on one side. All right. So if we add this, we're going to have the Laplace transform of cos AT. Oh my, it jump up all over, all the way up here. Plus what? Plus negative s squared over a squared. No, why am I saying plus negative? We're adding. So it's going to be plus s squared over a squared. So we have plus s squared over a squared times the Laplace of cos AT times the Laplace of cos AT, and that will be equal to, all right, so it's going to be equal to 1 over e to the st sine AT over a. Alright. Now since we have a minus here, because it says s divided by, and it is a negative e to the st. So we're going to have minus what now? S over e to the st cos AT over a squared. Now let us include the boundaries. It goes from 0 to infinity, and this of course is from 0 to infinity. All right, so this is equal to, now at infinity we're going to have 1 over e to the infinity, s time infinity, but 1 over this is 0, right? Time sine a times 0 is 0, and sine 0 is 0 over a minus, why I put sine 0 is 0? It's infinity. We're looking at the upper boundary, sine of infinity, minus, all right, so now we have 1, we're putting it 0 for this, 1 over e to the 0 sine 0 over a minus, now let's put in the boundaries for this one. We have s over e to the s times infinity, let's call it e to the infinity, cosine of a times infinity, which is infinity, over a squared, minus, now let's put in the 0 boundary, s over e to the 0 cos 0 over a squared. Now what do these things give us? Here, this is equal to 1 over infinity is 0. So it's 0 times sine of 0 is 0 over a minus. Now e to the 0 is 1. 1 over 1 is 1. Sine of 0 is 0, so it's 1 times 0 over a. So all of this part amount to 0. Alright? So all of this is gone. It's 0. Now minus e to the infinity is a very large number. And s over it, a constant over an infinitely large number, is 0. Cos infinity, we don't know what that is, but we only know that cosine range from -1 to +1. So it cannot go lower than -1 and it cannot go higher than +1. But anyway, whatever it is, that times 0 is 0. So the first part of this is 0 over a squared, which is 0, minus, alright, e to the 0 is 1. So this is s over 1, cosine of 0 is 1. So it's s over 1 times 1 over a squared. Now, of course, this will be s over a squared, alright? Now, we're not able to scroll down any further, so let's put a line there to divide the screen and continue up this line on the right hand side of this line. So let's do that. Here we have the Laplace transform of cos AT the Laplace transform of cos AT plus s squared over a squared Laplace transform of cos AT plus s squared over a squared times the Laplace transform of cos AT is equal to. Now what is that equal to? It's 0 minus this minus and this minus, we have a plus. This is s over a squared. So it's equal to s over a squared. Alright, let's factor out the Laplace transform of cos AT. The Laplace transform of cos AT inside the bracket will be 1 plus s squared over a squared is equal to s over a squared. Alright, nice. Now, the Laplace transform of cos AT is equal to, we divide both sides by 1 plus s squared over a squared. So we have s over a squared divided by, no, that will be divided by 1 plus s squared over a squared. Now, let us kind of simplify this. But before we do that, let us look at the table of Laplace transform and see what it says. Okay, here it says the Laplace transform of cos AT is s over s squared plus a squared. Let's see if we can fix this up to match what the table says. Let's write it down. S over s squared plus a squared. So it's supposed to be s over s squared plus a squared. Let's see what happens here. Suppose we consider using common denominators here. 1 is the same thing as a squared over a squared. You see that? So now, a squared plus s squared over a squared. You can combine these to make it a squared plus s squared over a squared. So let's do that. So let's put the s squared first to match what we have from the table. S squared plus a squared over a squared. Alright. Now let's do some fractions. This is the same thing as s over a squared multiplied by the reciprocal of this fraction here, a squared over s squared plus a squared. A squared cancel a squared. Okay, so if that is so, this a squared and this a squared, they cancel each other. So what we have is s over s squared plus a squared. So this s will go over s squared plus a squared. So here we have derived the Laplace transform of cosine at.